Have you ever wondered what an isolation transformer is and why it's important? Well, let's dive into it. An isolation transformer is a particular type of transformer designed to provide electrical isolation between its primary and secondary windings. It's like the peacekeeper in the world of electricity. Its main job? To transfer electrical power from a source to a device or system, and, in the process, prevent the flow of current between the two sides. It's like a middleman, ensuring that both sides are isolated from each other, hence the name. This isolation is crucial in many situations, especially where electrical safety is paramount. It helps reduce the risk of electric shock and other electrical hazards. So it's not just a transformer, but also a lifesaver. So in a nutshell, an isolation transformer is a device that helps ensure electrical safety and stability. Now, let's delve into some of the key features and functions of an isolation transformer. Firstly, electrical isolation. An isolation transformer has separate windings for the primary and secondary sides. These windings are not electrically connected, preventing the direct flow of current between the input and output. This feature is the essence of an isolation transformer, providing the isolation in its name. Safety is another crucial aspect. With the input and output isolated, the risk of electric shock and other electrical hazards is significantly reduced. This makes isolation transformers particularly important in situations where electrical safety is paramount. Voltage regulation is another feature of isolation transformers. Even when the input voltage fluctuates, they help maintain a stable output voltage. This can be particularly useful for sensitive electronic devices that require a consistent power supply. Next up, noise and surge suppression. Isolation transformers can suppress electrical noise and provide some level of protection against power surges and spikes. This makes them invaluable in applications where clean and stable power is crucial. Ground isolation is another key feature. Isolation transformers can create a separate ground reference for sensitive equipment, reducing the risk of ground loops and associated interference. Isolation transformers also have a role in medical applications. They ensure the safety of patients and medical equipment by preventing the passage of stray currents. In some electronic applications, isolation transformers are used for transformer coupling. They couple signals between different parts of a circuit without a direct electrical connection. However, it's important to note that although isolation transformers provide electrical isolation, they don't necessarily provide complete isolation from electromagnetic interference or radio frequency interference. For these purposes, additional filtering or shielding may be required. As you can see, an isolation transformer is quite a versatile device with a wide range of uses. You might be wondering, where are these isolation transformers used? Well, let's dive into the myriad applications of these ingenious devices. One of the most common uses for isolation transformers is in sensitive electronic devices. These devices need a stable voltage supply, free from fluctuations, to perform optimally. An isolation transformer ensures this by providing voltage regulation. Furthermore, it suppresses electrical noise and offers some level of protection against power surges and spikes, making it incredibly valuable in applications where clean and stable power is crucial. But the applications of isolation transformers aren't limited to just your everyday electronics. They play a hugely important role in medical settings too. Safety is paramount in these environments, and isolation transformers are often used to ensure the safety of patients and medical equipment. They prevent the passage of stray currents, which can be harmful, particularly in sensitive medical procedures. Isolation transformers don't stop at just protecting human lives. They also protect the integrity of electronic circuits. They're used for transformer coupling in electronic circuits, allowing signals to be coupled between different parts of a circuit without a direct electrical connection. This can be vital in complex electronic systems, where maintaining the integrity of the signal is crucial. In addition, isolation transformers can be used to create a separate ground reference for sensitive equipment. This reduces the risk of ground loops and associated interference. Ground loops can be a source of noise and can introduce errors in signal transmission, so having an isolation transformer can help to alleviate these issues. Finally, isolation transformers are often used in power supply units to provide safety and to eliminate noise. They play a vital role in ensuring that power supply units provide clean, stable power to the devices they're powering. So, whether it's keeping a hospital patient safe, ensuring your home electronics run smoothly, or maintaining the integrity of complex electronic circuits, isolation transformers are there, working behind the scenes to make it all possible. Whether it's keeping a hospital patient safe or ensuring your home electronics run smoothly, isolation transformers play a crucial role. However, like all devices, isolation transformers have their limitations. Despite their many benefits and applications, it's crucial to understand that isolation transformers are not the be-all and end-all of electrical isolation. In particular, while they excel at preventing direct current flow between their primary and secondary sides, they may not provide complete isolation from other types of interference. Specifically, isolation transformers might not fully shield against electromagnetic interference, or EMI, and radio frequency interference, or RFI. These types of interference can disrupt or degrade the performance of sensitive electronic devices and systems, and can be particularly problematic in certain applications, such as in telecommunications or medical equipment. To mitigate these, additional measures such as filtering or shielding may be necessary. So while isolation transformers do a great job at electrical isolation, they might need a little help when it comes to dealing with electromagnetic or radio frequency interference. So there you have it, a comprehensive overview of isolation transformers. These sophisticated devices play a crucial role in electrical safety and stability, providing electrical isolation, voltage regulation, noise and surge suppression, and even ground isolation. They're the unsung heroes in a multitude of settings, from medical facilities where patient safety is paramount to sensitive electronic devices that require clean, stable power. But remember, they are not without their limitations. While they excel at preventing the direct flow of current between input and output, they do not necessarily shield against electromagnetic or radio frequency interference. For these, additional measures might be needed. In essence, isolation transformers are a pivotal part of many electrical systems, silently ensuring safe and efficient power transfer. So remember, next time you're powering up your device, there might just be an isolation transformer working behind the scenes to keep things running smoothly.